Hello everyone, welcome to TryWrite, a new era of learning. This is Pack 365. In Module 2, yesterday, previous lecture, we discussed about depth first search in algorithm in AI, right? So now we're discussing Part D. In Part D, we are discussing about example problem in previous lecture. So start with it. So in previous lecture, we discussed about the robot, okay, a robot in maze stage. So we use the starting stage as 0, comma 0 and goal stage is 5, comma, sorry, 0, comma 5, right? So we have to travel the path to avoiding the obstacles, right? So here we have the output path 0, 0, comma 0, 1, comma 0, and this is our output. We want to print this output as a path. So we are instead, this is our output path. We have to print the output like this to travel by robot using to travel this paths, right? So this path we can explain here. So like this, the table will make sure here. So you can see here, we have a path and obstacles. We have this is the not disclosed areas. We did not travel those areas. So we have initial state 0, comma 0 to 0, comma 5 in one row and 0 point. We want to reach the goal state as 0, comma 5, right? So we can see here the goal stage is 0, comma 5. Now we want to initially travel the path. Okay. So we can travel to the goal, right? We start with initial state. We want to reach our goal. So it is we explain this in we learn this in theory way, right? So now in practical way, we want to do it. So our explanation code, we all know that already we have explained this step one, step two, step three, how to follow. So like this, we want to moving the steps to reach that. So for it now, open the VS Code, and now we want to create a file called DFS. Now we created a file. Now here we create the DFS file, dfs.py, depth first search. Okay. So from here, first I want to what I am doing maze, right? Maze dimensional. Maze dimensions and obstacles. So here I want to take a maze. I want to take a maze size here and take maze size has 6 and optical has, as I'm taking a list, anytime considering my 0, comma 1 and again 1, comma 1 and we have 3, comma 2. Yes, 4, 3, comma 4, right? Sorry, sir, I want to let you check. So what we want to travel those paths. 1, comma 3, comma 1. So yeah, where the opticals we have present like this black dot 0, comma 1, 1, comma 1, 4, comma 1 we have like we want to submit the opticals only, not the path. Right, 3, comma 3. Okay. So 3, comma 3. Now 3, comma 4. Now 3, comma 5. Again 3, comma sorry 0, comma 4. again 4 comma 1, 4 comma 2, 4 comma 2 and 4 comma 3. So I find the optical pair. So I want to mention the start stage, right? From start stage, what is our start stage? Starting stage is 0 comma 0, right? So I mentioned it, and what is my goal? And my goal is to reach the 0 comma 5, right? This is my goal state. So I clear it with my inputs goals. So now I want to check. Now I want to check whether a given position of x comma y is valid to move or not, right? So check once I use def is valid x comma y. I take as input. So from x comma y, wait a second. Here, okay, wait. Yeah, is valid. Return is zero. Is zero greater than equal to x, right? Is zero greater than equal to again. Sorry, zero smaller than x, x smaller than size, maze size, right? And we have operator. We're using the conditional operator here. So 0 comma again 0 smaller than equal to y, y smaller than maze size, and we again conditional use x comma y, we use x. So now not in obstacle, we use not in obstacles here. Okay, we return the function, and now we want to complete the DFS function of def first search. Now DFS def use function has I use DFS as. So my current, I using my current and visited. Wait a second. Where in the code am I? Okay, I use it current and I use it visited. I'm creating visited here and I use path. Okay, now x comma y equal to current, right? X comma y equal to current. If current is equals to, I am using current equals to goal, right? I want to reach the goal. So I mentioned the current equal to goal. If my current is equal to goal, I am putting the condition here. So if my current equal to goal, if I reach my current equal to goal, right, I want to append it for root from path dot append to current. I use path dot append to current and returns true, right? I want to return true. Now come back to visited. I want visited dot. I want to add current, right? In it, I want to add the current. So from it, I use moves like which move like I'm using the moves here. So I take a list in that I'm creating x minus 1 comma y and again x plus 1 comma y. Again I will x now it's y and now y minus 1 again y plus 1 here. x comma y plus 1 here. Okay. So we are moving the I move completed the move. For I know I want to append the current function. I want to those moves I want to add in the append. So for that I am using for move in moves. For move in moves, use if is valid. I'm using start to open back, open the moves all over moves. I'm opening it. And move not in visited. Now it's check. Wait, now it's check. If the condition. No, I'm using again. If DFS, if DFS moves and visit it, and I use again path. Here I will be putting condition. If my DFS is move visited path, if I visited the path and move visited, I am not visited here. If visited, move opening the moves, right? I'm opening all the moves by using search into star operator. So, and we are in conditional and move not in visited, right? If it is not visited, if DRF or DFS of moves visited path, so I'm adding that to path again, append it to current. So I'm appending it to again current. Now I want to again return it to true, right? Now I want to return this for again. I want to return false because if the state is false, it automatically takes the next stop. So overall, I completed the sum. If state completed, I want to return true. If not, I want to return false. If in case in that I want to return true, if the path is visited, I want to if the path is visited to current state equal to goal. So appending the path into the current, and my return statement is true. If I visited the moves and I want adding those moves into the paths, and if it is not visited, I want true, and if it is not visited, I want to false. If it is visited, it is not equal to it to move this to true. Okay, now I want to call the DFS function. I want to call the DFS function to find path. Now the main step you are using here path. So here I have completed the visiting. I have mentioned the path. Here my path is a visited function, right? So wherever I visited, first start from visit where I visited. So I use a variable visited equal to set a function called set, and already set it path. I'm mentioning the path equal to empty list, and am I using the empty list here? No, if DFS is start and visited and path, right? It goes and I come down, and now what I want to can do, now I want to do the path mention here, right? So I done that. I want to reverse, right? If the path I already visited, like I'm already the visited, so I want to track back it. So for the track back it, I want to use. So if I want if I visited the place, I watched, wait a second, where here spelling mistake. Yes, no, here I'm sticking that if I visit a place, if I did, so I want, if I get a dead end, so my path will be get reverse, right? So I use the reverse here. I reverse function, and then I want to print path found. right? So I want to get print the path found here. If for position I am giving for position in path, I am printing position. So if not it else, wait, I want to give the else for this. If I'm with the condition here, right? So if it else, so print, then my path is not found. No, no path found. Right. Okay. This is a function. So let do while we are let start the debugging here. There is no terminal and we want to run it. Let's check. We want to check where. Wait a second. I get a trackback call. Uh, Oh, it's a fixed. Wait, I want to run Python currently. Python. Wait. Hold on. Yes, it's fun. Now you can see, print the path. We path we found the zero. We founded the path right 0.11 comma 0. We founded the path. Okay, of what we are reaching right here. We founded those path. So this is the computation of this code. How would you get easy to understand in practical way? So we reached those path to complete the structure. Right? We reached those path to complete the structure. Okay. I hope you guys all of you understand about this expansion example. Thank you.